Good afternoon. Please find your seats as we're about to begin the School of Science Advanced Degree ceremony. We now welcome the academic procession. Please be seated and welcome Dean Nergis Malvalova.
Good afternoon, everybody. Good afternoon. Good afternoon, especially to our guests of honor, our graduates. Good afternoon, parents and families gathered here to celebrate the graduates of 2025. We have much to celebrate with our graduates and families and friends here today. I also want to acknowledge that this has been a profound year in which we have experienced a constantly shifting landscape of policies and executive orders that have resulted in concerns in both scientific and higher education communities, including here at MIT, including yourselves. We must continue to rally together and march forward for scientific progress and education. Yes. This will be a marathon with no clear precedent and no guaranteed finish line. We must return to our fundamental values, that basic fundamental science is critical to the health and prosperity of our country. That talent comes from all places and must be nurtured and supported. And that discoveries and progress are possible when our institutions of higher education are flourishing and not without the guarantee of support. Okay. Today, let us celebrate the stunning accomplishments of our graduating students. Students, you have made unprecedented scientific discoveries. You have learned, you have taught, you're earning your place among the most talented scientists in the world. You will make a better world with your science, with your conscience and activism, and most of all, with your empathy and regard for humanity. Yeah. Never stop being the catalyst for change you want to see in this world. Okay. Thanks. Families and friends, you may be wondering what kinds of achievements your graduates have made that have earned them the right to strut across the stage in this display of, shall we say, unique fashion? First and foremost, all our graduates have made indelible marks in their scientific fields, contributing to research that will have lasting impact on the next generation of scientists. You, our brilliant students, have contributed to our understanding of the progression of diseases like Alzheimer's, Parkinson's, and Huntington's disease. Using genetic, cellular, and systems-level analyses, you have identified targets that could one day lead to new treatments. You've investigated the neural circuits that underlie placebo's ability to relieve chronic and acute pain. You have confirmed that the Antarctic ozone layer is healing as a direct result of global efforts to reduce ozone-depleting substances. For the first time, you have observed a galaxy that shows scientists the complete picture of the hot to warm to cold phases of the formation of stars, the very things we're all made of. Using generative AI, you've come up with a new way to determine the three-dimensional structure of our genome, predicting thousands of structures in just minutes, making it speedier than existing experimental methods. You've also used AI tools to generate realistic satellite images of future flooding, helping communities visualize and prepare for approaching storms that will not only increase as the Earth's climate changes, but more rapidly. And others of you have uncovered findings that suggest the control of RNA splicing, a process that is fundamental to gene expression, is more complex than previously known. You've developed new ways to reprogram immune cells and direct them towards anti-tumor immunity, one more piece in the puzzle of eradicating cancer. Still others of you have determined that atomic-level interactions prevent peptide bonds from being degraded, which is why we still see collagen in fossils nearly 200 million years old. And who doesn't love to learn more about dinosaur collagen? Okay. Your scientific achievements are part of your legacy, as is your service to the community, to your communities, and to MIT. Your passionate advocacy helps us all to strive towards becoming our better selves, whether it's pushing our climate and sustainability efforts forward, advancing our knowledge in life, health, or quantum science, or mathematics, or ensuring that your voices are heard through demonstrations and dialogue. I want to draw your attention to one little appreciated skill you have acquired in the course of your studies. You have learned to practice healthy skepticism. You have been skeptical. How do you trust your apparatus? How do you interpret your data? How do you convince yourself and your colleagues of your findings and your conclusions? You have infused your work with skepticism and have overcome it with data and reason. So, when you meet skepticism or outright hostility towards science, speak out in all the ways you already know, with data-driven conviction. And when you think it's not a fair or rational conversation, think of all the times that you have had to address ridiculous referee comments to publish your papers. Okay? You know how to do this. So this then is my challenge, my charge to you. Think about when and how you stand up for your values. Like your newly minted degrees, standing up in the face of uncertainty, oppression, and ignorance isn't easy, and the path is not straightforward. Lean on those in your community who have helped you grow and achieve what you have today, many of whom are here with us. So, do great science, believe in its value to humanity, and speak your passion and knowledge not only to your colleagues and well-wishers, but especially to those who are skeptical. Don't stop standing up for what you believe in. Yeah. On behalf of the School of Science, the Woods Hole Oceanographic Institute, and all of MIT, we recognize and congratulate you. We celebrate your graduation from MIT, my beloved alma mater, and now yours. This year's commencement speaker and I go quite a ways back. In some sense, you might say we go back 1.3 billion years. Okay. Now, I know that the position of dean has aged me somewhat, but we all can agree that that would be a stretch to make such a claim. So more properly, Dr. Franz Cordova and I have been colleagues in adjacent fields of physics for a long while, but partners in wonderment and amazement for the last 10 years. 10 years ago, Franz Cordova was the director of the National Science Foundation when scientists, including myself and my colleagues here at MIT, made the announcement that we had seen, for the first time, an astrophysical event predicted by Einstein nearly 100 years before. The collision of two massive black holes, 1.3 billion light years away, caused what Einstein called gravitational waves, and the instrument conceived of and built by scientists and engineers from MIT and Caltech detected these waves for the first time. And Franz, as director of the NSF, the country's most prestigious scientific agency, got to preside over that announcement to tell the world what we had seen. And it was a truly amazing moment for us both. As a Caltech alumna and researcher herself, Franz's scientific contributions have been in the areas of observational and experimental astrophysics, multispectral research on X-ray and gamma-ray sources, and spaceborne instrumentation. She has published more than 150 scientific papers and numerous science policy papers. She was a co-principal investigator for a telescope experiment that is currently flying on the satellite XMM Newton, a cornerstone mission of the European Space Agency. Franz has been elected to the National Academy of Science, the American Academy of Arts and Sciences, the American Philosophical Society. She is also a fellow of the American Association for Advancement of Science and the Association for Women in Science. She has held multiple leadership roles in leading research and education institutions across the country, but perhaps her most important role in this time of uncertain federal funding for scientific research and education France is currently the president of the Science Philanthropy Alliance, whose mission is to advance science through visionary philanthropy. We are delighted to have Dr. France Cordova here. Please join me in giving her a very warm welcome.
Thank you very much, Dean Nergis, and hello, everyone. I'm just thrilled to be here. Thank you to the MIT administrators, faculty, and staff for inviting me to join you today. To all our new biologists, neuroscientists, chemists, earth, atmospheric, and planetary scientists, mathematicians, and physicists, you're going to be making the breakthroughs that are going to amaze and transform our world. Congratulations, class of 2025. What a difference today makes. We're celebrating a signature moment in your life. It's a time to be joyous for reaching this milestone. And it's a time to remember and thank all those who brought you to this moment, your family, your friends, your teachers. Let's applaud them all. I remember when I achieved the milestone you've reached today. I can say without exaggeration that up to the moment, it was the happiest day of my life. And why? Because I felt I had achieved something that few thought I could, or would, or even should. My parents were more concerned that I hadn't found a husband, but we'll come back to that later. Only a handful of fellow students appreciated that deciphering previously undetected signals from the cosmos, specifically detecting rapid pulsations from accretion-driven compact stars in close binary systems, would bring me intense joy and introduce new questions for research. After all, it was in line with my childhood aspiration to be a detective, to solve mysteries. I envisioned as a child that I could invent a Dick Tracy watch that I could use to talk to others. And today, I have one. You have one. It's called an Apple Watch. I didn't invent it, but I imagined it, and my generation did make it. And now it's your turn. You made your journey to this day. You were driven by curiosity and piloted by an inner light that wouldn't give out. You stepped into the wondrous world of hypothesis, data, discovery, interpretation, reflection, and eureka. New mysteries were born. You did something no one else did before you. This degree from MIT reflects the moment when all of that comes together and you're ready to begin a new adventure. Speaking of MIT, I owe my start in science to this institution. I had finished a degree in English literature from Stanford and found myself living in Harvard Square, working with a Harvard Junior Fellow on a new concept for higher education. I had been accepted to Stanford's graduate school in anthropology based on my work as an undergraduate on the sociology of bilingualism in a Zapotec pueblo in Oaxaca, Mexico. But I wanted a gap year, and this I spent here in Cambridge. One evening that summer, I watched a Nova-like documentary on the recent discovery of neutron stars. A young female graduate student in England had discovered rapidly pulsing signals in her radio data. Some news correspondents hypothesized that the periodic pulses of radio light were signals from a far-away intelligence. There was talk in newspapers of LGM, Little Green Men, but more sober minds ascribed the signals to compact, rotating stars at the end of their stellar lives. And a light went off in my brain. It struck me that what I wanted to work on was to detect and understand signals from the cosmos. Those, after all, were the greatest mysteries. The next day, I found myself taking a bus down Mass Ave to MIT. I knocked on the door of one of the scientists interviewed in the documentary. Hearing of my interest, and I'm sure half amused by this English major, he took me to the Center for Space Research, now the Kavli Center, where I met a few faculty members and said I would work for nothing. And I was hired, although legally with pay. I was given the task of reduction of balloon data on X-ray emission from unknown sources in the cosmos. I was also to help with the bibliography of the first review of the new field of X-ray astronomy. Years later, I thought perhaps my mentors thought that as an English major, I might be helpful in editing. I worked hard, and by the end of the summer, I was admitted to MIT as a graduate student at large. I didn't know there was such a thing, but there I was. Had I appreciated that if I had stayed, I would have merited a brass rat ring, I might not have left for Caltech. I do love that ring. But I did leave MIT and eventually got a graduate degree in physics at Caltech. So I consider MIT my first home as a scientist because of the reception and encouragement I got here. When, on that first visit, one space scientist made a diagram on his blackboard of a radiative process and wrote the word Bremsstrahlung across it, I was captivated. That was it. It was like a baby has its first word, doggy or daddy. My first word as a newbie to science was Bremsstrahlung. For those of you who don't know physics or German, it means breaking radiation. Today, I hope that my grandson, who lives in nearby Concord and did his science fair project on the origin of the Big Bang, will one day be an MIT student. Nergus, start recruiting, but you have time. He's just 6 years old. So fast forward through more than 4 decades. I observed the heavens with many telescopes in space and on the mountaintops of many continents. I published papers in astrophysics, served in university leadership positions, and worked for several federal agencies, including NSF as director and NASA as chief scientist. Memorable things happened over that long time, and I want to share with you one of the most remarkable, and it was already alluded to by your dean. I was sitting in my office at the National Science Foundation when the head of the Math and Physical Sciences unit came in and said, "Do you want to hear some good news?" Mind you, at the time, there was little of that. It was late 2015. Some in Congress, no surprise, were challenging some of NSF's grants. Sound familiar? Which we defended based on the gold standard of peer review. The NSF budget was flat, and it had been so for a long time. We argued for an increase. The social and behavioral sciences were threatened. And suddenly, without warning, the earth shook. The entire earth shook. The head of the math and physical sciences walked into my office to tell me that important news. I was told that an experiment NSF had funded for 4 decades for the purpose of detecting gravitational waves from dramatic events in the cosmos had made a convincing detection. The Earth was jiggled ever so slightly by a passing gravitational wave. LIGO, a laser interferometer, had detected a ripple in space-time, and our planet was caught in that ripple. Well, this may sound pretty esoteric to those of you who are not physicists or astronomers. Esoteric, perhaps, but with a huge wow factor. It was a major technological achievement on the part of MIT and Caltech scientists who developed and managed the large experiment in 2 locations, Louisiana and Washington State. It was an accomplishment that Einstein himself thought would not be possible because the detection would amount to a movement less than 1/10,000th the width of a proton. That's where the genius of MIT people like Ray Weiss and your Dean Nergis Mavalvala come in. They are innovators who had the vision to pursue and accomplish their dream. I was amazed. So many naysayers over the previous decades had insisted this experiment was tilting at windmills. So many NSF directors and a very committed program officer had defended the goal and the hefty price tag. I asked so many questions about that first detection. I was so worried that it could be a spurious signal, maybe a little earthquake, a satellite mishap. How thorough were the checks on this? And in the end, I was satisfied that a large team of scientists had done everything possible to validate that result. And the second remarkable part of the story, for years, the LIGO team had led a computational effort to deduce what kind of sources could produce gravitational waves. They had carefully modeled those scenarios with supercomputers. The methods that many of you have used in your own research, matched filtering, machine learning, simulations, real-time processing, were critical in determining the origin of that signal. So by the time there was a detection, these computer scientists could say that the signal was produced by the collision of two large black holes, each about 30 times the mass of the sun. And Dean Nergis has already told you how far away they were when they joined each other, a distance of 1.3 billion light years. That was absolutely amazing that we could detect something so small and that we could know what caused it. This discovery verified the predictions of Einstein's general relativity, and all over the country, students hung signs around statues of Einstein saying, "I was right." 2 months later, after everyone involved was certain of the results, we held a press conference at the National Press Club in DC, and they told us, their staff there, that was the biggest press event that they had ever had at the National Press Club. I was the lucky person who introduced the first detection of gravitational waves on Earth to the world. I introduced the MIT and Caltech scientists who made the announcement and described its significance. And they even produced the sound of the merger of the two black holes. It was a watershed moment, followed by many more detections with LIGO, including one a couple of years later using a third detector, this one in Italy. And indeed, the gravitational wave discoveries are due to collaborations now from scientists all over the world. And today, LIGO has detected more than 100 such mergers of black holes and also neutron stars. And as a result, we understand much more about the population of black holes and much more about the production of heavy elements like the ones in our rings, elements like gold and platinum from mergers of neutron stars. And in 2017, only 2 years later, the Nobel Prize in Physics was awarded to LIGO scientists, MIT's Ray Weiss and Kip Thorne and Barry Barish from Caltech. I attended the Nobel ceremony. Many from MIT were there. It was a joyous time for science and scientists. LIGO had begun the era of multi-messenger astrophysics, and we could now observe the heavens with gravitational wave detectors in addition to electromagnetic wave telescopes. Well, there are many lessons in my stories, and here are my 10 pieces of advice drawing on my experience for you graduates. First, your passion is yours alone. Don't let anyone tell you that you're too young or too old or too anything. Someone once said when I thought about being an astronaut, and I was, wow, almost 30 years old. Well, that's too old to be an astronaut, but hey, you know, we've had people up there who are decades older than that, and so much more. Let others be bounded by their prejudices. You should be unbound by your dreams. One of you will be the next Einstein or Marie Curie, and let let that person be you. Second, don't give up just because you feel you don't have enough whatever, experience, age. No one has enough of everything they think they need. What you do have is just enough to succeed. We value genius, but we depend on the pollinators, the spreader of ideas for discovery. And third, salary is not your principal goal at this point as you make a career change or start a new challenge. You're working towards a goal that will set you on your life's journey. Fourth, don't be afraid of change at any point in your life. Change is filled with hope and expectation. Change stimulates the imagination, and change can lead to breakthroughs. That includes change of place. I've moved so many times. When my son was about 8 years old, he wrote his first composition in the class. They were asked, where have you lived? And he said, I've moved 6 times. Well, everything you learn in one phase of your life is transportable to the next phase. So there's no time that's wasted. It's all part of you becoming your unique self. 6, pursue your curiosity and let the data lead you to the truth. That's the path to a unique contribution. Many Nobel Prize winners began their scientific investigations as practically as outcast or ignored. A recent example is Kari Kariko, whose work was not respected for decades. She couldn't hold on to a job. Her work on mRNA saved the world with the development of the COVID vaccine. She won the Nobel Prize in 2023. So forget about approval. Focus on your detective work. Appreciate the convergence of disciplines in discovery. We know the origin of gravitational waves we detect because of engineering, computer science, and physics, and probably more working together. And 8th, about being a boss. I learned that being the head of a federal agency has its rewards as well as its challenges. Black holes can do their thing and headline newspapers, dazzling even the naysayers. I learned that being the head of a university also has its rewards, realized especially at commencement time when you look at the hopeful faces of so many bright graduates and their families. And it has its challenges. For example, if your football team, my football team at Purdue, was not headed to the Rose Bowl, or if you're leading in this challenging moment. Taking on a leadership challenge requires a strong backbone, and you have it. It's reputed that Einstein said, "In the midst of every crisis lies a great opportunity." Your challenge may be to turn crisis into opportunity. That's all of our challenges now. And 10th, on a personal note, you'll find that someone who can be your life partner. My own someone took a while to pop into my life. He came in the form of a rock climber swinging over to meet me on a rope high on the cliffs above the Rio Grande River. We've been together more than 40 years. So my parents shouldn't have worried. The important thing about a partner is that they are truly a partner. They support your dreams and you support theirs. Note that my stories were about MIT. Be grateful you graduated from MIT. It's filled with creative people. The School of Science is dedicated to innovating in science. It's given you a great skill set, wise colleagues and mentors, and friends from all over the world. Your experience here will open doors. It allows you to wear that brass rat ring, and more importantly, it gives you an authentic voice for science and its infinite possibilities. And one more piece of advice: celebrate, graduates, you did it!
Thank you so much, France. What a wonderful story of your life. And thank you for all of that advice. I hope you all were paying attention and will follow it. Good things will happen if you do. France is a good example of that. Now, really on to the reason we're all here today, our graduates. So at this moment, I have some official language that has to be infused into our ceremony to make you all official. It's very fancy, so pay attention. Okay. The faculty of the School of Science are declared convened, together with this assembly, for the conferring of master's and doctoral degrees, including the investiture of the doctoral academic hood. The academic hooding ceremony is a symbol of dedication to scholarship and attainment of the doctoral requirements defined by the Academy. I am proud to now introduce you to MIT's newest scholars.
Course 5, Chemistry, Master of Science in Chemistry.
Frida Angern. Marissa Allen.
Course 8, Physics, Master of Science in Physics.
Pin Chun Cho. Andrea Perry. Jacob Willis.
Course 9, Brain and Cognitive Sciences, Master of Science in Brain and Cognitive Sciences.
Quiley Simeon.
Course 12, Earth, Atmospheric and Planetary Sciences, Master of Science in Earth and Planetary Sciences.
Abigail Colclaser. Sarah Wells Moran. Jack Payette.
Master of Science in Physical Oceanography, jointly by the Massachusetts Institute of Technology and Woods Hole Oceanographic Institution. Christian Meyer. Investing hoods for the Doctor of Philosophy on behalf of the Department of Biology, Professor Mary Gehring, David Baltimore Chair in Biomedical Research.
Neha Bokil. Shannon Moreno. Hannah Jacobs. Emma Coel. Callista Deal. Cesar Dominguez. Hannah Harris. Wentao Huang. Alex Cruswick. Christian Loyo. Gayatri Muthukumar. Supinya Satitlo Sakun. Bonnie Sue.
Cassandra Vondrak.
Samantha Webster. Erica Wirachman. Tong Zhang.
Investing Hoods for the Doctor of Philosophy on behalf of the Department of Brain and Cognitive Sciences, Professor Mark Baer, Picower Professor of Neuroscience.
Audrey Effenberger. Madison Echevarri Leet. Maxwell Heinrich. Francis Riley Andujar. Minyoung Kim. Greta Tuchkote. Nicholas Waters. Margaret Schroeder. Isaac Treves. Vincent Tong.
Investing hoods for the Doctor of Philosophy on behalf of the Department of Chemistry, Professor Troy Van Voores, Department Head and Hassam and Dewey Professor of Chemistry.
Yasmin El-Faraj. Abraham Herzog Arbeitman.
Isabella Borgula Pearl.
So Young Lee. Lindsay Nowak. Alan Carter. Melanie Halim. Hao Shangfang. Johan Lau. Ifu Ouyang. Christopher Choklov. Rihanna Greer. Jessica Jian Kim. Catherine Badding. Eric Riesel. Jude Deschamps. Shirley Chen. Madeline Hoffman. Sarah Quinn. Suhyun Lim. Greg Schuett. Channon Sessler. Amog Sood. Noah Somberg. Xin Sui. Sung-Yun Yi. Hannah Toru. Stephanie Smeliansky. Sophia Wang. Juchuan Zhang. Wenchao Ma. B. Yuan Eric Tra. Levi Waring.
Tara Sverko.
Ji Min Yoon. Amanuela Mengiste. Weizi Yuan.
Investing Hoods for the Doctor of Philosophy. On behalf of the Department of Earth, Atmospheric and Planetary Sciences, Professor David McGee, Department Head, and William R. Kennan, Jr., Professor of Earth and Planetary Sciences.
Matthew Baldus. Hilary Chung. Rola DeBook. Ishar Dutta. Fatima Hussein. Brenda Kanaya. Zifan Lin. Daniel Ortega Arroyo. P.J. Tuckman. Pei Dong Wang.
Investing Hoods for the Doctor of Philosophy. On behalf of the Department of Mathematics, Professor Michel Gomans, Department Head and RSA Professor of Mathematics. Nivan Achinga.
Mo Chun. Ryan Chen. Zihong Chen. Evan Chen. Anlong Chua. Alex Cohen. Marissa Gates. Sarah Greer. Mitchell Harris. Andre Hessen. Cameron Krylewski. Tang Kai Lee. David Jongwon Lee. Nicholas Liu. Wei Xiao Lu. Nitya Mani. Zhi Ren. Zhao Xin Rui.
Investing hoods for the Doctor of Philosophy on behalf of the Department of Physics, Professor Lindley Winslow, Associate Department Head.
Samuel Alipur Fard. Blocks Bloxam. Rikab Gambir. Rahul Jayaraman. Wayo Kituni.
Nicholas Demos.
Wen Xuan Jia. Yevgeny Knyazev. Gianni Lavecchia. Mikhail Kona. Jeffrey Krupa. Eunice Lee. Yukun Lu. John Martin. Daniel Mayer. Jeffrey Moe. Paul Neves.
Patrick Orr.
Xiaowei O. Caliroy Papas. Chong Nan Peng. Zhengyan Shi. Oriol Rubies Bigorda. Caitlin Shin. Benjamin Stein Lubrano. Jinggang Xiang. Yifan Su. Zhiren Zheng. Daniel Swartz. Joshua Wakefield.
Investing Hoods for the Doctor of Philosophy, on behalf of MIT and the Woods Hole Oceanographic Institution, Professor Mick Follows, Director of the MIT Hui Joint Program and the Rudge 1948 and Nancy Allen Professor of Oceanography. Brenna Bayman.
Emma Bullock. Jinxi Shen. David Geller McGrath. Catherine Halloran. Alexandra Jones Kellett. Ariana Krinos Quinn. Glenn Leo. Julia Maddalena Stranga. Benjamin Tiger.
Sean Wang.
Jane Weinstock.
Congratulations. As we conclude the investiture of doctoral hoods and degree conferral ceremony, I now invite the faculty to join me in a salute to welcome this year's doctoral graduates to the Academy. One more round of applause for you. We also congratulate our master's degree recipients for their outstanding academic achievement. And now, graduates, I give you a chance to applaud everybody who has helped you get to this place today, all around you. An applause for all of your supporters. Let us also offer a round of applause and thanks to the dedicated staff who have put together today's advanced degree ceremony. Thank you so much, all of you are here around us. So with your graduation today, and believe me, there can be no skepticism about your hard-earned degrees, the faculty of this institution recognize the achievement of our advanced degree recipients. Congratulations to you all. So, family and friends, I ask that you remain in your seats until our faculty and graduates have exited to the lobby. Once they've exited, please join us for a reception just outside this building in the tent beyond. Congratulations. This is, for me, one of the happiest days of the academic year, and it's because of you. Congratulations, and thank you.